ESR measurements. The samples can be reused after the NMR and ESR measurements. NMR active compounds are generally diamagnetic, whereas ESR active compounds are paramagnetic. In NMR, radio frequency waves of lower energy, as we have seen earlier, is required in megahertz, whereas in ESR, the energy of splitting is larger. Therefore, microwave radiation of higher energy is required to cause the transition between the two swing states. In NMR, the relaxation times T1 and T2 are of high value, whereas the relaxation times of electron spin states are very much shorter, 0.1 to 1 microsecond. The relaxation times are extremely short. Therefore, because of this, NMR is usually measured at room temperature because of the high relaxation times 0.1 to 1 second. We'll see what are relaxation times in further in slides. The EPR is measured at lower temperature because of the fact that the short relaxation time. In NMR, the signals observed measured as absorption signal because of the short relaxation times. Line widths are larger. It will exhibit broad EPR spectrum. Therefore, the ESR signals are measured as the derivative signals. In NMR, the line width is very much lower, whereas in ESR, the line width is larger of 1 Gauss because of the short relaxation time. Similarly, the resolution in NMR is very high because of the lower line width, whereas the resolution in NMR is very low because of large line width. However, NMR is very less sensitive. We need 1 millimolar concentration to measure the NMR spectrum. For example, if the sensitivity is lower, then we need large concentration of the sample to measure the NMR spectrum. Whereas in the case of ESR, it is very sensitive. Therefore, even 1 nanomolar is enough to measure the ESR spectrum of your compound. In NMR, the coupling constant is expressed in joules, whereas in ESR, the hyperfine splitting constant is expressed in Gauss. The splitting is very much greater the ESR compared to NMR. In NMR, we need different probes to record the spectra of different nuclei. Different probes are required, whereas in the case of ESR, EPR, the resonances of different paramagnetic species can be measured in a single run using the same spectrometer. Whereas we need to change the probe for proton NMR, C13 NMR. In this case, using the same EPR spectrometer, we can measure the iron EPR spectrum, copper 2 EPR spectra, and vanadium EPR spectra, and other free radical EPR spectra.